Hi class, this is part 3 of section 4.3 on quadratic functions and their properties. Example 3a, determine the equation of the quadratic function whose vertex is 2, 1 and whose y-intercept is 0, 13. Okay, so we have our two forms of a quadratic function. So the first one is y is equal to ax squared plus bx plus c. The second one is vertex form, so it's a times the quantity x minus h squared plus k. For this problem, since we're given the vertex, I think it'll be easiest to use the vertex form. Okay, so the vertex is our hk. So the point hk is the point 2, 1. So we can plug in a 2 for the h and a 1 for k. This would lead to y is equal to a times x minus 2 quantity squared plus 1. Okay, so now we just need to determine what a is, and then we'll be done. So we'll use the fact that the y-intercept is 0, 13. So this means that when x is equal to 0, y must equal 13. So let's substitute a 13 for the y variable. A is what I'm looking for. X is 0. Okay, so I have my vertex form. I'm just replacing x and y with 0 and 13, since that was the y-intercept that I was given. Okay, so 0 minus 2 is negative 2. Squared will be 4. So I have 4 times a plus 1 equaling 13. Subtract 1 from both sides, and we'll have a 12 on the left-hand side. So 12 is equal to 4 times a. Divide both sides by 4, so a is equal to 3. Okay, so the equation of our parabola is 3 times x minus 2 quantity squared plus 1. We were not told to leave the answer in standard form, right? So we don't need to FOIL it out and distribute the 3. We're allowed to leave it like this in vertex form. Okay, so I'm going to go through the problem one more time. So again, you have the option to use either vertex form or standard form. Since we're given the vertex, it makes sense to use the vertex form of the parabola. Okay, so we were given the points 2, 1 as the vertex. So plug in a 2 for h and a 1 for k. Now we need to find a, and then we're done. Okay, so again, this right here is vertex form of our parabola, where the h value has been replaced with 2, and the k value has been replaced with the 1. Okay, again, just figure out what a is, and then we're done. So to determine a, we need to use the second piece of information that we're given. So the fact that the y-intercept is 0, 13. If instead of being given the y-intercept, if you're given a different point on the graph, you still simply replace the x value with what you're given, and then the y value with what you're given. Okay, so plug in a 13 for y and a 0 for x. Solve, and we'll come up with a is equal to 3. So again, subtract the 1 over and then divide by 4. Good, and then just state your final answer. Again, it's fine to leave your answer in vertex form. Okay, so f of x is equal to 3 times the quantity x minus 2 squared plus 1. Okay, this one, example 3b, you're going to complete and turn in through Canvas. Determine the equation of the quadratic function whose vertex is negative 4, negative 1, and whose graph goes through the point 1, negative 51. So this is very similar to example 3a, which we just did together. Okay, finally, we want to determine whether the quadratic function has a maximum or a minimum value, and then we want to find that value. Okay, so with this function here, we see that we have a positive leading coefficient, which tells us the graph will open up. So if your graph opens up, then there must be a minimum value. Okay, that value will occur at the vertex. So basically this question is asking us to find the vertex. Okay, so the x-coordinate of the vertex, if you remember, is negative b over 2a. Negative b for this problem is the opposite of negative 4. So we're back to positive 4 over 2 times 1 or 2. So 4 over 2 is 2. Okay, the maximum, or in this case the minimum value, is going to be the y value. So we need to plug in a 2 for the x and see what we get back. So f of 2 is going to be 2 squared, which is 4, minus 4 times 2, which is 8, and then we add 7, so we get 3. Good. So the minimum value is 3. If you're asked where that minimum value occurs, then the answer is 2. But if you're just asked for the minimum value, it's the y value. So in this case, it's the number 3. Okay, that's it. Let me know if you have any questions.